Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to evaluate this equation here. We are told that we are supposed to find the integral of root x over 2 minus x from 0 all the way to 1. And we are going to apply a technique known as U-Substitution in order to work out this. Now, the first thing that we ought to do here is that we need now to substitute u so that this integral that we have at this particular point can be able to be in terms of u so that we can be able to start our integration. If you are new to Proflan YouTube channel, consider subscribing so that in time we are going to upload a new video like this one, you'll be notified. Now, we're going to start by treating this kind of equation. We get to understand what are we going to substitute, because at the denominator we're going to substitute u, because at the denominator we have what we are supposed to be having. So we need to know under root x, what are we going to substitute at that particular point. So we are going to rewrite this equation using this equation we are given. We can say that our root x, of course, we are having that u is equals to 2 minus root x, which will mean we can be able to take root x on this side and u on the other side, and we shall have root x is equals to 2 minus u. So meaning that anytime we have root x, we can be able to substitute that or replace with 2 minus u. And something else also we need to remember, this equation that we have at this point, we need to know what dx is. Dx, what is it equivalent to? So what I'm going to do at this point here, after realizing that I can replace this with 2 minus u, this equation here, I need now to find what dx can be replaced with, because we're going to write the whole expression with u. So I can be able to say from this expression that we have at this point, we can say this is root x is equals to 2 minus u. I can square both. Now we're going to have x is equals to 2 minus u raised to power 2. Now I want to differentiate this function with respect to u. So this is going to become dx du is going to be equals to, if I differentiate this part, we are going to use what we call chain rule. Now, using chain rule at this point, we are going to say that the power will brought down, so we shall have 2 minus u, and we shall decrease the power by 1, so that will be 2 minus 1, that's going to be power 1. Then we are going to multiply this expression that we have gotten here by the differentiating what is inside the bracket. So differentiating what is inside the bracket, 2 minus u, that's going to be negative 1. So at the end of the day, this is going to reduce to what? This is going to reduce to du, this is going to reduce to dx du is equals to minus 2 into 2 minus u. Then now I can be able to multiply both side by du, and I'll have the expression which is what? Dx is equals to this du multiplied on the other side, we shall have minus 2 into 2 minus u du. So we can see now, anytime we're going to have dx, this one is going to be replaced by minus 2 minus u du. Now let's rewrite the expression in terms of u now, and we are going to say now the expression that we have here, we can, at this point, x is equals to 0 and x is equals to 1. Also, we need to write these values of x in terms of u before we start replacing everything. So this is going to be when u is x is equals to 0. what is the value of u in that? So we're going to say u is going to be equals to 2 minus square root of 0, and our u is going to become 2. When x is equals to 1, our u is going to be what? U is going to become 2 minus square root of 1, and that is going to translate to a square root of 1 is actually 1, so it's going to translate to 1. So meaning we can now substitute, but you can see now when x is 0, u is 2. When x is 1, u is also 1. So we're going now to substitute everything, and we're going to write our integral. It will start from 2. When x was 0, u became 2. When x was 1, u became 1. And root x can be replaced with 2 minus u. So we're going to say 2 minus u, everything over. 2 minus u can be replaced with 2 minus root x. 2 minus root x can be replaced with u. And then we are going to have dx. But dx, we said, can be replaced with this. Yes. So we're going to have, of course, this is together. So we times negative 2 into bracket 2 minus u, then du. So having this expression, we can be able to take the constant out, and I'll be reducing this to negative 2 out. I'll take the negative out of the integral sign, and then we're going to have 2 minus u into bracket 2 minus u, then du, but everything is under u. Now every term here is having, or is in terms of u. So you see the bigger number here is the lower limit, yeah. So and the smaller number is at the top. So if we can be able to switch those numbers, we are going to change the sign of the integral to a negative sign. So if we want to take this up and this down, this integral is going to change by a negative sign. And if you introduce that negative sign by switching this position of 1 and 2, it will also affect this negative sign that we are having at this given point. So we are going to have positive 2 here. So I can now change that to 1 all the way to 2, but I'll have positive 2 into 2 minus u over 2, rather, over u du. So you see now, since I switched the position of 1 and 2, I have to introduce a negative sign. And since we are having a negative sign here, so we have now a positive value. Okay, so at this point, I think we are good. We need to at least expand this and get to simplify and see what we shall have. So this will start from 1 all the way to 2. Expanding this, we shall have 4 minus 4u plus u squared over u, then du. So having this, we are going to divide every term we have here by u, so that we can be able to simplify them and have the expression simplified for integration. So 4 divided by u is going to give us what? So let me just write these 2 at this point, and I think I need to let me write this 2 here. Shall have 2 integral of from 1 all the way to 2. 4 minus u, it will be 4 over u, minus 4 u over u, that will reduce to just 4. U over 2 over u squared over u, that's going to translate to just u. And once you do that, you integrate with respect to u. Okay, we are going now to integrate term by term before applying that. So we are going to say this is 2 into bracket. Integrating this, it becomes 4 ln of u integrating this, it becomes 4 ln of u, minus integrating this, it becomes 4u, and then plus this one, it becomes u squared over 2, and the limit is from 1 all the way to 2. So that is basically what we have now. We can be able to substitute the limits so that we can be able to check what we're gonna get. So this is going to be 2 into bracket, substituting now 2 into every term here. We are going to have 4 ln of 4, 4 ln of 4, okay, no, 4 ln of 2 minus 2 here. We shall have 4, that will be 8 because it will be 4 times 2, then plus 2 squared over 2, that will be 4 over 2, that will be now 2, minus into bracket, substituting 4 ln of 1, 4 ln of 1, then minus 4, then plus 1 over 2, 1 over 2, then we shall enclose everything there like that. Now simplifying what we have, we shall have 2 into bracket, 4 ln of 2 will just remain 4 ln of 2. This will be minus 6, and of course I need just to keep things clean. Ln of 1 is 0, so it will be minus 0. So this is 4 times 0 minus 4, and then plus a half. So basically whatever we are going to have in bracket here will be just simplified to 4 ln of 2, because we're going to leave our answer in exact form. Let's try to see what we are going to have this equal to, because I'll be having minus 6. This is actually minus 6. Minus minus becomes plus 4 minus 1 over 2. So let us see, minus 6 plus 4, that will be negative 2. Negative 2 minus 1 over 2, it will be reducing to 4 ln of 2 minus this is going to translate what to 5 over 2, right? 5 over 2, right? Because it will be minus 2.5, isn't it? Yes. So if we simplify this, basically I see I'm going to reduce this to 8 ln of 2 minus 5 as our final answer, minus 5 as our final answer. So basically this is the final answer we are going to get after performing this particular integration. If you are new to Proflan YouTube channel, consider subscribing so that in time I'm going to upload more tutorials for video like this. You'll be notified. In Proflan, we do matters physics and math, A levels, IGCSE, GCSE. So if you are one of the candidates who's going to do exams, more videos will be popping up. So see you in the next video.